Everybody, my name is Destiny, and for today's lesson, we are going to be learning systems of linear equations and all that comes with it. So, for this first question, it's asking us to determine whether the ordered pair, which is going to be negative 2, comma 0, is a solution to the system of linear equations below. So, linear, sorry. So, linear equations are just two equations at the same time, and right now it's asking us to find a pair, the ordered pair, that works in both equations. So, this point is going to be called the solution. And since it's already given us a point, we're going to find out if this is a solution to both of these or not. So in order to do that, we're going to look at our ordered pair and we're going to label our x's and our y's. Sorry, my thing is kind of glitching out on me. Sorry about that. Okay. So negative 2 is going to be our x and 0 is going to be our y. Now, what we have to do is plug this into each x and each y. So I'm going to do this first one. And I'm just going to plug it in. And I'm going to put them in parentheses to know that we are multiplying. That was going to be a very big 0, but I just decided to make it a parenthesis. And then we're going to just do this one first, and we'll do this one next. So 8 times negative 2, and I'm going to write it on this side. 8 times negative 2 is going to give me negative 16. So what you see in blue is the answers. And then it's going to be minus 3 times 0, which is going to be 0. And this is actually going to equal negative 16, which is good. That means that this ordered pair is a solution to the first linear equation. And now we're going to solve this second one. So for it to be a solution, it has to match both equations. So just keep that in mind. We're going to again replace the x's and y's. And we're going to rewrite it out here. So 5 times negative 2 is going to give us negative 10. And this one is plus 2 times 0, which is going to give us 0. And this is going to leave us with negative 10. So as you can see here, this answer was supposed to be negative 41, but we have negative 10. So that means that this does not match. This pair does not match this. So like I said earlier, we have to get both of them to equal what this is in order for it to be a solution. So in this case, negative 2 comma 0 is not a solution to the system of the linear equations. So I'm just gonna put no solution. So the first question is fairly easy, and after a couple of times you start to get it even more, just because this is one of the easiest, if not the easiest, questions that you'll get when you're dealing with the systems of linear equations. So moving on to question 2. It is asking us to find the solution to the system of linear equations below using elimination or substitution method. So for this one, I'm going to be using the substitution method. So I'm just going to underline it just to let you know what we're going to be focusing on this question. Okay, there we go. And I'm going to use a different color just so that way nobody is confused. Let me actually use green. So for this one, sorry about that. So for this one, we're going to solve the second one first because it's really easy to get x by itself. All we have to do is subtract y, and what we do on one side we have to do from the other. So positive y minus y cancels out, and we have to do it to the other side. So therefore leaving us with x equals negative 6 minus, oops, so sorry, there's not a negative there. Okay, so now we are going to actually take this negative 6y and plug it in right there because x equals negative 6y. So to do that, I'm actually just going to type it out in the text box just because this handwriting is getting a little outrageous. And I would like it to be a little more neat, just so that way nobody gets confused. Negative 4y. And we're just going to add the rest of the problem. Oops, I'm just messing up everywhere here. Okay. So now we are going to solve this, and this is going to be fairly easy. 3 times 6 is going to give us 18, and then 3 times negative y is going to give us negative 3y. And then again, we're just going to bring down the rest of the problem. Equals 31. So now we're going to be combining like terms just to make this a little more easier. Negative 3y plus negative 4y is going to give us negative 7y. And then again, just bring down the rest of the equation. 31. Okay, so now we're going to try and get negative 7y by itself. So in order to do that, like we did for this, we are going to subtract, and what we do on one side, we do have to do to the other. So positive 18 and negative 18 are going to cancel each other out, and then we're actually going to add negative 18, and then we're just going to bring this down along with the solution. So negative 7y equals negative 49. So now we're going to be focusing on getting y by itself. So in order to do that, we have to divide, and I am cutting into question 3, but it's okay. I will erase it, or actually I'll just do it on this other side. So I'm going to move this over here. So negative 7y is going to be negative 7y is going to be divided by 7, which is just going to leave us with y. And then negative 49 divided by 7 as well is going to leave us with 7. I'm sorry, negative 7 divided by negative 7y divided by negative 7 is going to leave us with y. And negative 49 divided by negative 7 is going to leave us with 7. Sorry about that. So now that we have y equals 7, we're going to plug this 7 in place of this y. And we are going to be using this to find our x. So x equals 6 minus 7, which is going to give us -1. Let me see if I can fit that here. -1. Okay. So now we have to write it as our ordered pair. So our x is going to be -1. So -1, and then our y is going to be 7. So this is going to be our ordered pair, aka the solution using the substitution method. Now moving on to question 3. Let me erase this bottom right here. Oh, that's okay. So for question 3, it's asking us again to find a solution using either the elimination or substitution method. And in this case, I'm going to be using the, I don't know why I'm clicking it. So in this one, I'm going to be using the elimination method since we just used the substitution method for 1. And for 2, I don't see any easy equation that would be faster for me to get x by itself. Sorry, I need to get a little sip of water there. So our step 1 is we are going to be choosing a variable to eliminate. So we have to use elimination to get rid of one variable. And I noticed that the second equation has a -y and the first one has a +2y. And we can make those match so we can cancel the y's. So we have, for step 2, we have to make the y terms opposites. So if we multiply the second equation by 2, and I'm just going to put this in brackets like this. If we multiply the second equation by 2, we'll get -2y, and that will cancel out the +2y in the first equation. So what I'm going to do now, I'm going to write it on this side. So 2 times 5x is going to, and I'm just going to add this here since we are going to be canceling the y's between the two. So that means we're going to add both equations together. So 2 times 5x is going to give me 10x. And then 2 times -y is going to give me -2y, which was what I was just talking about now. And then we're going to do 2 times 41, which is going to give me 82. And now we're going to be adding the equations together. So 7x plus 10x, and let me use a different color here. So 7x plus 10x is going to be 17x. 17x. And then the positive 2 plus y and then negative 2y. Sorry, the positive 2y and the negative 2y cancel each other out. Therefore, we're just going to add the 71 and the 82, which is going to give me 153. So now we're going to try to give this x by itself. So in order to do that, I have to divide by 17. I'm going to divide by 17 here as well. And this is going to give us, oh, I'm sorry. Let me erase that for you. This is going to give us x equals 9. So now that we have this one, we just solved this bottom equation. So now we have to solve this top equation. I'm sorry. Since we found x here, I'm just going to plug it into this bottom one. Sorry about that. Because it's just easier since y is already by itself. So I'm going to add this, and I'm just going to rewrite it here. So 5 times 9 minus y equals 41. And then we're just going to add these together. I'm sorry, multiply these together. So this is going to give me 45. That looks a little wonky. Let me just rewrite it for you guys. Okay, 45, and then we're going to bring down the rest of the equation equals 41. Okay, so now we're going to try and get this by itself. So in order to do that, I'm going to subtract 45, and that's going to cancel out. And what we do on one side, we have to do to the other. And I'm running out of space, so I'm just going to write the thing here. And it's going to leave me with negative y equals negative 4. And I'm just going to get rid of the negatives here. And which will leave me with, which is going to leave me with y equals 4. So since we have our x and we have our y, the only thing we have to do here is just create our solution as we did in the second question. So x is going to be 9, I'm sorry, and our y is going to be 4. This is kind of looking like a 4, so let me fix that for you guys. 4. So this is going to be our solution for question 3. Now question 4 is asking us to do the same exact thing. And this one looks a bit tricky, but I noticed that this second equation is kind of like the first one. It just happens to have smaller numbers. So what I can see is that each one has 3, and then this common, the multiple of this one is going to be 3. So I'm just going to multiply this second equation by 3. And again, I'm going to put it in brackets as I did this one. And then I'm going to solve it as well. So 3 times 3 is going to give me 9. 3 times 3x, I'm sorry, it's going to give me 9x. And then 3 times y is going to give me 3y. And then equals this times this is going to give me negative 12. So now our system is going to be, and then I'm just going to put a big old blob over this so we can focus on these two. So our system is now going to be 9x plus 3y equals negative 7. And then the second equation is going to be 9x plus 3y equals negative 12. So the left sides are exactly the same, but the right sides are not. One says -7, as we see here, and then this one says -12. So something is wrong because, like I said, in order to find a solution, they both have to be matching, as this one right here. So this means that the two lines are actually parallel, so they never meet. That's why there's no solution. And these equations look similar, but they'll never cross. So for example, if we have this 9x plus 3y equal -7, and we have the same exact equation here, but we have a different solution, it means that these two are parallel, but our equations are not, meaning they are not a solution, and we actually won't find a solution. So that means that we have another no solution.